Hello and welcome back to our channel where we dive deep into computer science and programming concepts. Artificial intelligence has made great strides in recent years, and one area where this is particularly evident is in the realm of games. AI has been programmed to play games like chess against human opponents and has proven to be a formidable adversary. The ability of AI to analyze large amounts of data and make decisions based on complex algorithms has enabled it to compete with some of the best human players. While human players still hold an edge in terms of creativity and intuition, AI has continued to close the gap, and many experts predict that it will eventually surpass human players in games like chess. Today, we are going to talk about a start search algorithm and how it can be used to solve the 8-number puzzle problem. The 8-number puzzle is a simple puzzle where you have a 3x3 grid with 8 numbers and a blank space. The goal is to rearrange the numbers to form a specific order, such as 1, 2, 3, 4, 5, 6, 7, 8, and blank space. To make it more concrete, let's take an example. Here is our initial configuration of the 8-number puzzle. The goal is to find the shortest solution to reach the goal configuration, which is 1, 2, 3, 4, 5, 6, 7, 8, and blank space. The A-star algorithm solves this problem by using a priority queue that stores the states to be explored based on their heuristic value f of n, which is the sum of the cost to reach the state and the estimated cost to reach the goal from that state. First, we put the initial state as 0 in the queue and calculate its f of n value as the estimated cost to reach the goal from that state. We can use the Manhattan distance as the heuristic estimate. Then, we extract the state with the lowest f of n value from the queue and mark it as visited. Next, we expand the extracted state by generating all possible moves of the blank space and adding them to the queue. We also update their f of n values and keep track of the parent state for each state. And here are the all possible states generated from state S0 with possible actions of moving the blank space up, left and right. For state S0, moving the blank space down is not possible as it is in the last row. So down is invalid action of state S0. We are calculating the heuristic values of all newly generated states S1, S2 and S3. We are calculating the Manhattan distance between the tile's current position and its position in the goal state. Here are all generated states with its heuristic values. We put all generated states in the queue along with its heuristic values. Now the queue gives priority to the state which is having minimum heuristic value, which is S3 in this case. We repeat steps 2 and 3. Until we reach the goal configuration or the queue becomes empty. Finally, we backtrack from the goal configuration to the initial state by following the parent states of each state to find the shortest solution. And there you have it, the shortest solution to the 8-number puzzle using the A-start search algorithm. Now, I will show you a demo with the implementation. I have the 8 puzzle game as well as my implementation of A-star search opened on screen. I'm adding the initial state configuration as same as the configuration shown in the puzzle game. I'm running the script and let's see what is the output. Here is the output, where we got the list of actions to take in order to solve the puzzle. I'm replicating the actions in the puzzle game. Check the description for the link to the Python program solving 8-number puzzle using a star search in Jupyter Notebook. The puzzle is solved in just 19 moves. I hope this video has been helpful in understanding how the A-star search algorithm can be used to solve the 8-number puzzle problem. If you have any questions or feedback, feel free to leave them in the comments below. And don't forget to like and subscribe for more computer science and programming content.